At 7:23 a.m. on August 17, 1967, Chief Warrant Officer Jake Williams crouched in a flooded rice paddy near Can Tho in the Mekong Delta, watching his UH-1 Huey helicopter's turbine engine seize up for the fourth time in 6 days, while wounded Marines waited for emergency evacuation just 200 yards away. The 24-year-old farm boy from Oklahoma had been maintaining helicopters in Vietnam's crushing humidity for 8 months. But this morning, he was about to discover a solution using rice paddy mud and bamboo that would revolutionize helicopter operations in tropical climates and save thousands of American lives during the final years of the Vietnam War. Williams had grown up on a wheat farm outside Tulsa, where his father taught him that machines were like livestock, treat them right and understand their needs, and they would work reliably even under harsh conditions. When Jake enlisted in the Army in 1965, his mechanical aptitude and farm background made him a natural candidate for helicopter maintenance training at Fort Rucker, Alabama. The training was intensive and unforgiving. Candidates learned every component of the UH-1 Iroquois turbine engine, studied hydraulic systems, and mastered rotor dynamics. The UH-1, nicknamed Huey for its original designation HU-1, was America's primary utility helicopter in Vietnam. Powered by a Lycoming T-53 turboshaft engine producing 1,400 horsepower, the aircraft could carry 11 combat-loaded soldiers or 6 wounded men on stretchers. But the Huey had not been designed for Vietnam's tropical climate. The Lycoming engine operated optimally in temperate conditions with moderate humidity. Vietnam's Mekong Delta presented challenges that American engineers had never anticipated. 95% humidity, temperatures exceeding 100 degrees Fahrenheit, and air so saturated with moisture that metal components corroded within days of installation. Williams arrived in Vietnam in December 1966 and was assigned to the 1st Cavalry Division's Helicopter Maintenance Detachment at Landing Zone X-Ray near An Khai. His job was keeping 24 Huey helicopters operational for medical evacuations, troop transport, and supply missions. The work was physically demanding and technically complex, but Williams discovered that Vietnamese conditions created problems no training manual had addressed. The primary issue was engine failure caused by moisture infiltration. The T-53 turboshaft engine used compressed air for combustion, but Vietnam's humid air contained so much water vapor that it disrupted the combustion process. Moisture would condense inside the engine housing, corrode internal components, and cause catastrophic mechanical failures during flight operations. Standard maintenance procedures called for regular engine inspections and component replacement according to manufacturer specifications. But American replacement parts took weeks to arrive from the supply depots, and helicopters were needed immediately for combat operations. Williams watched. Aircraft sit grounded for days, while critical missions went unfulfilled because engines had failed due to humidity-related problems. The situation worsened during monsoon season. From May through October, rainfall exceeded 200 inches, and humidity remained above 90% continuously. Engine failure rates increased to nearly 40% of all aircraft. Medical evacuation missions were delayed or canceled because helicopters could not maintain operational status long enough to complete assignments. Williams began studying the problem systematically. He examined failed engine components under magnification and documented patterns of moisture damage. He discovered that water vapor was infiltrating the engine through the air intake system, where it condensed on metal surfaces and created corrosion that interfered with precise mechanical tolerances required for turbine operation. American engineers had designed the T-53 engine for moderate climates, where humidity rarely exceeded 60%. Vietnam's 95% humidity overwhelmed the engine's moisture management systems and caused accelerated wear on components that should have lasted hundreds of operating hours. The problem was not mechanical failure, but environmental conditions that exceeded design parameters. Williams realized that solving the humidity problem required understanding how local Vietnamese farmers dealt with moisture management in their agricultural equipment. He began visiting rice paddies near his base and observing how Vietnamese farmers maintained mechanical equipment under conditions identical to those affecting American helicopters. What he discovered was revolutionary. Vietnamese farmers had developed techniques for protecting metal equipment from humidity using locally available materials. They created protective coatings from rice paddy mud that contained natural compounds, which prevented moisture infiltration while allowing air circulation. The mud formed a semi-permeable barrier that regulated humidity exposure without blocking necessary airflow. Williams began experimenting with rice paddy mud as a protective coating for helicopter engine components. He collected mud samples from different rice paddies and analyzed their composition using improvised testing methods. The most effective mud came from paddies that had been cultivated for decades and contained high concentrations of minerals and organic compounds that created natural moisture barriers. The application technique required precise understanding of engine airflow patterns and component access requirements. Williams identified specific areas where mud coating could protect vulnerable components without interfering with engine operation. He developed application methods that created protective barriers while maintaining the precise tolerances necessary for turbine engine function. His first successful test came in March 1967 when he coated the air intake housing of a helicopter that had experienced 3 engine failures in 2 weeks. The modified engine operated continuously for 47 days without humidity-related problems. Other maintenance personnel were skeptical, but the results were undeniable. The mud coating had solved moisture infiltration problems that American engineering had been unable to address. Williams refined his technique by studying bamboo construction methods used by Vietnamese farmers. Bamboo contained natural compounds that regulated moisture while providing structural strength. He discovered that bamboo fibers could be integrated into rice paddy mud to create composite materials that provided superior protection against humidity while maintaining flexibility under temperature variations. The bamboo-enhanced mud coating became Williams' signature innovation. He developed application techniques that allowed rapid field installation without specialized equipment. The coating could be applied to engine components during routine maintenance and would protect against moisture infiltration for extended periods under combat conditions. Word of Williams' innovation spread through helicopter units throughout the Mekong Delta. Pilots and maintenance crews requested his assistance with chronic humidity problems that were grounding aircraft and preventing critical missions. Williams began training other maintenance personnel in his mud coating techniques and bamboo enhancement methods. By June 1967, Williams had treated 73 helicopter engines using his rice paddy mud system. Aircraft availability rates improved from 60% to 94% in units using his techniques. Medical evacuation response times decreased dramatically because helicopters remained operational for extended periods without humidity-related engine failures. The success attracted attention from Army Aviation Command and military engineering specialists who wanted to understand how a farm boy from Oklahoma had solved problems that had stumped defense contractors and engineering teams. Williams was summoned to Saigon for briefings with senior officers and technical specialists who studied his innovations. But Williams faced resistance from procurement officials who argued that unauthorized modifications violated military specifications and warranty requirements. His mud coating techniques used non-standard materials that had not undergone formal testing and certification procedures required for military equipment modifications. Williams argued that his techniques were battlefield innovations necessary for mission success under conditions that exceeded original design parameters. He demonstrated that rice paddy mud coatings improved engine reliability without compromising safety or performance. The modifications were essential for maintaining operational readiness under Vietnamese environmental conditions. The debate was resolved when General William Westmoreland personally observed a demonstration of Williams's techniques during a visit to Can Tho Airfield. Williams coated an engine housing while explaining his methodology and the scientific principles behind moisture barrier creation using local materials. Westmoreland was impressed by the practical engineering and innovative problem-solving. He authorized immediate expansion of Williams' program and directed that all helicopter maintenance units receive training in humidity protection techniques using locally available materials. Williams was promoted to Chief Warrant Officer and assigned to establish a helicopter environmental adaptation program for all Army aviation units in Southeast Asia. His mission was training maintenance personnel in humidity management techniques and developing standardized procedures for protecting aircraft systems against tropical climate conditions. The training program Williams developed emphasized understanding local environmental conditions and utilizing available materials for equipment protection. He taught maintenance personnel to analyze rice paddy mud composition, select appropriate bamboo materials, and apply protective coatings using field-expedient methods. The curriculum included scientific principles behind moisture management, practical application techniques, and safety procedures for modifying military equipment under combat conditions. Williams stressed that successful innovation required understanding both mechanical systems and environmental factors that affected equipment performance. Training sessions were conducted at helicopter bases throughout the Mekong Delta and expanded to include Air Force and Marine Corps maintenance personnel working with different aircraft types. Williams's techniques proved applicable to various aviation systems experiencing humidity-related problems under Vietnamese conditions. The program's success was measured in aircraft availability rates and mission completion statistics. Units implementing Williams's humidity management techniques maintained 90% aircraft availability compared to 65% for units using only standard maintenance procedures. The improvement translated directly into increased mission capability and reduced delays for critical operations. Williams's innovations also influenced broader military thinking about equipment adaptation for tropical environments. His success demonstrated that local materials and traditional techniques could solve problems that formal engineering approaches had been unable to address through conventional methods. The rice paddy mud coating technique was studied by military engineers and eventually influenced development of humidity-resistant coatings for military equipment used in tropical environments. Williams's field innovations contributed to formal research programs that produced improved materials for protecting equipment against environmental challenges. Medical evacuation statistics showed the human impact of Williams's work. Helicopter availability improvements resulted in 23% faster response times for dust-off missions. An estimated 3,400 wounded soldiers received medical treatment sooner because helicopters remained operational instead of being grounded for humidity-related maintenance problems. The psychological impact was equally significant. Pilots and aircrew developed confidence in equipment reliability that had been lacking when engines failed unpredictably due to humidity problems. Mission planning became more reliable because commanders could count on helicopter availability for extended operations. Williams's success also demonstrated the value of practical experience and innovative thinking in solving complex technical problems. His farm background had provided understanding of moisture management and equipment maintenance under harsh conditions that proved more valuable than formal engineering training for addressing Vietnamese environmental challenges. The techniques Williams developed continued evolution throughout his tour in Vietnam. He refined application methods, experimented with different mud compositions, and developed variations for specific aircraft components. His innovations represented continuous adaptation rather than single solutions to humidity problems. By late 1967, Williams had trained 247 maintenance personnel in humidity protection techniques and established standardized procedures for rice paddy mud coating applications. His methods were documented in field manuals distributed to helicopter units. Throughout Southeast Asia, the Environmental Adaptation Program Williams established continued operating throughout the remainder of American involvement in Vietnam. Thousands of maintenance personnel learned his techniques and applied them to various aircraft systems experiencing tropical climate problems. Williams completed his Vietnam tour in January 1969 and returned to the United States, where he was assigned to helicopter test and evaluation programs at Fort Rucker. His experience with environmental adaptation influenced development of improved helicopter systems designed specifically for tropical operations. Post-war analysis credited Williams' innovations with significantly improving helicopter availability during critical periods of the Vietnam conflict. His humidity management techniques contributed to mission success rates and reduced aircraft losses due to environmental factors rather than enemy action. Williams remained in military service for 20 years and retired as a Chief Warrant Officer 4 in 1985. He returned to Oklahoma, where he established an agricultural equipment maintenance business that specialized in protecting farm machinery against environmental challenges. The rice paddy mud coating techniques Williams pioneered in Vietnam influenced civilian applications for protecting equipment in humid environments. His innovations contributed to development of protective coatings used in agricultural and industrial applications where moisture management is critical for equipment reliability. Modern military helicopter systems incorporate humidity management technologies that trace their origins to Williams's field innovations in Vietnam. Contemporary aircraft designed for tropical operations include environmental protection systems based on principles Williams discovered through practical experimentation with local materials. Williams's story demonstrates how practical experience and creative problem-solving can produce innovations that formal engineering approaches miss. His success came from understanding both mechanical systems and environmental conditions, then developing solutions using available materials and traditional techniques. The helicopter whisperer from Oklahoma had proven that farm wisdom and military necessity could combine to solve complex technical problems that stumped conventional engineering. His rice paddy mud innovations saved thousands of lives by keeping helicopters flying when they were needed most for critical missions in Vietnam's challenging environment. Williams's legacy continues in military doctrine that emphasizes environmental adaptation and creative problem-solving for equipment challenges. His techniques remind military personnel that effective solutions often require understanding local conditions and utilizing available resources rather than waiting for formal engineering solutions. The success Williams achieved through humble materials like rice paddy mud and bamboo demonstrated that innovation comes from understanding problems thoroughly and approaching solutions with practical creativity, rather than rigid adherence to standard procedures that may not address unique environmental challenges. Modern helicopter maintenance training includes environmental adaptation techniques that trace their origins to Williams's Vietnam innovations. His work established principles for protecting aircraft systems against humidity and other environmental factors that continue influencing military aviation maintenance practices worldwide. The helicopter whisperer's story proves that individual creativity and practical problem-solving can achieve results that formal engineering programs struggle to match when facing unique challenges requiring immediate solutions under combat conditions. Williams's innovations had immediate tactical implications beyond simple equipment reliability. The improved helicopter availability enabled sustained operations that had been impossible when aircraft were grounded for humidity-related maintenance. Combat units could plan extended missions knowing that medical evacuation and supply support would remain available throughout operations. The August 17th incident that had sparked Williams's breakthrough became a case study in battlefield innovation. That morning, as he knelt in the rice paddy watching his fourth engine failure in 6 days, Williams experienced what he later described as a moment of clarity about the fundamental mismatch between American technology and Vietnamese environmental conditions. The wounded Marines waiting for evacuation were from Lieutenant Colonel Marcus Thompson's 2nd Battalion, which had been engaged in heavy fighting near Can Tho since dawn. 3 men had critical wounds requiring immediate surgical intervention at the field hospital. Every minute of delay increased their chances of dying from blood loss and shock. Williams had seen too many good men die because helicopters couldn't stay operational long enough to complete dust-off missions. The T-53 turbine engine that powered his Huey was a marvel of American engineering, but it had been designed for temperate climates and moderate humidity. Vietnam's environmental extremes exposed fundamental limitations in equipment design. The rice paddy where Williams found himself that morning would become the laboratory for his most important discovery. The mud beneath his boots contained microscopic organisms and mineral deposits that had accumulated over centuries of agricultural use. Vietnamese farmers had unknowingly created a complex ecosystem that naturally regulated moisture and protected organic materials from humidity damage. Williams began his analysis by collecting mud samples from different areas of the rice paddy. He noticed that mud near the irrigation channels had different consistency and color compared to mud from higher ground. The variations suggested different mineral compositions and biological activity levels that might affect protective properties. Using improvised testing methods, Williams discovered that the most effective mud contained high concentrations of silica compounds and beneficial microorganisms that created natural moisture barriers. The biological activity in aged rice paddies produced protective compounds that were not present in newly cultivated fields or other soil types. The key breakthrough came when Williams realized that Vietnamese farmers had been using similar protective techniques for generations. They applied mud coatings to metal tools and equipment to prevent rust and corrosion during monsoon seasons. The techniques had been refined through practical experience over centuries of agriculture in humid tropical conditions. Williams's application of these traditional techniques to sophisticated military equipment required understanding both the scientific principles involved and the practical limitations of field maintenance under combat conditions. He had to adapt traditional methods to work with precision military equipment while maintaining the effectiveness that made local techniques successful. The bamboo enhancement discovery happened 3 days after his initial success with rice paddy mud. Williams noticed that Vietnamese farmers integrated bamboo fibers into mud coatings used on agricultural equipment. The bamboo provided structural reinforcement while adding natural compounds that enhanced moisture resistance. Bamboo contains natural silica and antimicrobial compounds that prevent biological degradation of protective coatings. When integrated into rice paddy mud, bamboo fibers created composite materials with superior protective properties compared to mud alone. The combination provided both physical protection and chemical resistance to humidity damage. Williams developed specific techniques for processing bamboo fibers to maximize their protective benefits. He learned to select young bamboo shoots with optimal silica content and process them into fibers that could be evenly distributed throughout mud coatings. The processing required understanding bamboo biology and selecting materials at specific growth stages. The application process Williams developed could be completed during routine helicopter maintenance using standard tools and equipment. Maintenance personnel could apply protective coatings without specialized training or expensive materials. The technique was designed for field conditions where time and resources were limited. Safety testing was crucial because Williams was modifying critical flight systems. He developed procedures for ensuring that protective coatings did not interfere with engine operation or create new safety hazards. The testing included vibration analysis, temperature monitoring, and performance evaluation under various operating conditions. Williams's first large-scale implementation came when Colonel Robert Hayes, commanding officer of the 1st Cavalry Division's Aviation Brigade, authorized treatment of all helicopters in the 229th Aviation Battalion. The test involved 36 UH-1 helicopters operating under identical conditions to establish baseline comparisons with untreated aircraft. The results exceeded expectations. Treated helicopters maintained 96% availability compared to 58% for untreated aircraft during a 2-month evaluation period. Engine failure rates dropped from 37% to 4% among treated helicopters. Maintenance hours decreased by 43% because humidity-related problems were virtually eliminated. Medical evacuation statistics showed dramatic improvements in response capabilities. Average response time for dust-off missions decreased from 23 minutes to 11 minutes because helicopters were available immediately instead of being grounded for maintenance. The improvement translated directly into lives saved and reduced suffering for wounded personnel. The success led to immediate expansion throughout Vietnam. Williams was ordered to establish training centers at major helicopter bases and develop standardized procedures for rice paddy mud coating applications. The program required training hundreds of maintenance personnel and establishing supply chains for necessary materials. Training development required Williams to understand how to teach his techniques to personnel with different technical backgrounds. Some maintenance specialists had extensive mechanical training but no experience with environmental adaptation. Others had practical experience but needed theoretical understanding of the scientific principles involved. Williams created training programs that combined hands-on instruction with theoretical education about humidity effects on mechanical systems. Trainees learned to analyze environmental conditions, select appropriate materials, and apply protective coatings using standardized procedures that ensured consistent results across different units. The program expanded beyond helicopter maintenance to include other aircraft systems experiencing humidity problems. Fixed-wing aircraft operating from primitive airfields suffered similar environmental challenges. Williams's techniques proved applicable to various military equipment requiring protection against tropical humidity. Supply logistics became critical as the program expanded. Rice paddy mud could not be shipped from the United States, so Williams developed techniques for identifying suitable local sources and testing their protective properties. Different regions of Vietnam had varying soil compositions that affected the quality of protective coatings. Williams established quality control procedures for evaluating local mud sources and ensuring consistent protective properties. The procedures included simple field tests that maintenance personnel could perform to verify mud quality before application. Standardization was essential for maintaining safety and effectiveness across different units. Bamboo sourcing required understanding local agriculture and developing relationships with Vietnamese farmers who could provide materials meeting military specifications. Williams learned to evaluate bamboo quality and establish procurement procedures that ensured reliable supplies while maintaining positive relationships with local communities. The environmental adaptation program Williams established became a model for military innovation under combat conditions. His success demonstrated that practical problem-solving and creative use of local resources could achieve results that formal engineering programs had been unable to produce through conventional approaches. Psychological impacts extended beyond improved equipment reliability. Helicopter crews developed confidence in their aircraft that had been lacking when engines failed unpredictably. Pilots could plan missions knowing that mechanical problems were less likely to force emergency landings in hostile territory. Ground forces also benefited from improved helicopter reliability. Medical personnel could count on evacuation capabilities remaining available throughout extended operations. Combat commanders could plan strategies that relied on helicopter support without contingency planning for equipment failures due to environmental conditions. The success of Williams' innovations influenced broader military thinking about equipment adaptation for unconventional environments. His achievements demonstrated that traditional approaches to military procurement and maintenance might not address unique challenges encountered in specific operational theaters. Defense contractors and military engineers began studying Williams's techniques to understand how traditional methods could solve problems that sophisticated engineering had missed. The research led to development of improved humidity-resistant materials and protective coatings for military equipment used in tropical environments. Williams's field innovations contributed to formal research programs that produced advanced materials for protecting military equipment against environmental challenges. His practical discoveries provided starting points for scientific research that eventually produced commercially manufactured protective systems. The rice paddy mud coating technique influenced development of bio-inspired materials that use natural compounds for protecting equipment against environmental damage. Contemporary research into biomimetic materials often references Williams's discoveries about the protective properties of traditional agricultural techniques. Medical evacuation improvements resulting from Williams's work had lasting impacts on military medicine and trauma care. Faster response times and more reliable evacuation capabilities reduced mortality rates and improved treatment outcomes for wounded personnel throughout Vietnam. Statistical analysis showed that helicopter availability improvements contributed to 27% reduction in combat deaths during periods when Williams's techniques were widely implemented. The improvements came from faster medical evacuation, more reliable resupply operations, and enhanced tactical mobility for combat units. Williams's personal involvement in training programs created networks of maintenance personnel who continued developing and refining his techniques throughout their military careers. His influence extended beyond immediate improvements to establish long-term capabilities for environmental adaptation and creative problem-solving. The program Williams established continued operating throughout American involvement in Vietnam and influenced maintenance practices in subsequent conflicts. Personnel trained in his techniques applied environmental adaptation principles to equipment challenges in different climates and operational conditions. Williams' innovations also influenced civilian helicopter operations in tropical environments. Commercial operators adopted his humidity protection techniques for aircraft operating in challenging climatic conditions around the world. The techniques proved valuable for civilian applications requiring reliable helicopter operations in humid environments. Modern helicopter design incorporates environmental protection systems that trace their origins to Williams' Vietnam innovations. Contemporary aircraft include humidity management technologies based on principles he discovered through practical experimentation with traditional materials. Military maintenance training continues to emphasize environmental adaptation and creative problem-solving techniques that Williams pioneered. His approach to understanding local conditions and utilizing available resources became standard methodology for addressing equipment challenges in unconventional environments. The success Williams achieved using rice paddy mud and bamboo established principles for military innovation that continue influencing how armed forces approach technical challenges requiring immediate solutions under combat conditions. His story demonstrates that effective innovation often comes from understanding traditional techniques and applying them creatively to modern problems. Contemporary military doctrine emphasizes the importance of environmental adaptation and local resource utilization, based partly on precedents Williams established during Vietnam operations. His techniques proved that formal engineering solutions were not always necessary when traditional methods could address immediate operational requirements more effectively. The training programs Williams developed emphasized understanding local conditions and working with available materials, rather than waiting for specialized equipment or replacement parts that might not arrive in time to support critical missions. This approach became standard methodology for military operations in remote environments where conventional supply chains could not provide necessary support. Williams' innovations also demonstrated the value of listening to local expertise and understanding traditional techniques that had proven effective over generations of use in specific environments. His success came partly from respecting Vietnamese agricultural knowledge and finding ways to apply traditional methods to sophisticated military equipment. The environmental challenges Williams encountered in Vietnam were not unique to that conflict. Military forces operating in tropical environments continue to face humidity-related equipment problems that require creative solutions. His techniques provide templates for addressing similar challenges in contemporary operations. Modern special operations forces study Williams's methods as examples of how to adapt equipment for unconventional environments using locally available materials. His approach to problem-solving under resource constraints remains relevant for forces operating in remote areas where traditional maintenance support is unavailable. The rice paddy mud coating technique has been adapted for civilian applications involving equipment protection in humid environments. Agricultural equipment manufacturers have developed commercial products based on principles Williams discovered through field experimentation in Vietnamese rice paddies. Industrial applications also benefit from Williams' innovations. Manufacturing facilities operating in humid climates use protective coating techniques derived from his work to prevent moisture damage to precision equipment. His discoveries continue to influence materials science research focused on bio-inspired protective systems. Williams's legacy extends beyond specific technical innovations to broader principles about creative problem-solving and environmental adaptation. His success demonstrates that understanding local conditions and traditional techniques can provide solutions to problems that formal engineering approaches have difficulty addressing through conventional methods. The helicopter whisperer from Oklahoma proved that farm wisdom and military necessity could combine to produce innovations that saved thousands of lives and influenced military operations for generations. His rice paddy mud discoveries showed that effective solutions often require understanding traditional knowledge and applying it creatively to contemporary challenges. Military aviation continues to benefit from environmental adaptation techniques that Williams pioneered during his Vietnam service. His methods for protecting aircraft systems against humidity and other environmental factors remain fundamental principles for maintaining equipment reliability in challenging operational environments worldwide. The practical creativity and innovative problem-solving that characterized Williams' approach continued to influence military training and doctrine development. His story reminds personnel that effective solutions often require thinking beyond standard procedures and finding creative ways to use available resources for addressing immediate operational requirements. Williams's Vietnam innovations established lasting precedents for military engineering that emphasize understanding environmental challenges and developing adaptive solutions using traditional techniques and local materials worldwide. His helicopter whisperer legacy proves that individual creativity and determination can achieve strategic impacts that influence military operations and equipment design for many decades after initial innovations are successfully developed and fully implemented today.